Okay. Good morning, everyone. Uh, this is Rinath from the COSO R&D team. Along with me, Uni and Guru has joined us this particular session. Today, we are planning to give you an overview of the COSO data consumption as well as COSO as a platform. What are the things it does? How the suits are using it, and then building a suit specific or meeting a specific requirement. So to start with, the COSO is basically a platform, right? And then the main idea of this particular session is to walk you through the various and the capabilities, as well as give you an overview of the architecture, how actually the configuration flows, as well as the data which gets ingested from the suits can flow, and followed by how actually somebody can extract the data. And also probably we will be going through an overview of the various streaming mechanism which is available within the COSO, and few of the things like preload and postload, what actually are there, that we will try to cover. In case of any question, please type in your question in the chat. My colleagues will be able to answer you in real time, and probably we'll have a Q&A session towards the end to discuss in detail anything further which is needed. So let's jump on to the overall architecture, and I try to understand various components which is involved. This particular black diagram gives you an overview of the various components which are present in the COSO. Having said that, if you really look at before we even jump in internal of the COSO, we can see that COSO as a platform is available as a deployment module through Helm charts. So this is the first part in which we will deploy the COSO, and then the next thing is once we deploy, basically we need to provide the configuration information. So how somebody can provide the configuration information? The configuration information is nothing but which are the data sources, which it will data sets which gets ingested. So those information need to be provided. So that will be done through this administration module. Post the configuration, the data will be get ingested into the system, right? So this data ingestion can be done in various mechanisms. One is directly putting the data into the HTTP receiver, and then or if they are they can also write into the pulsar proxy. This pulsar is basically a messaging subsystem which involves which provides basically a streaming module in which it holds the data for the guaranteed message delivery, and expectation is that with zero message loss, it holds the message until the data which gets loaded or put into the Vertica system, Vertica database, right? So this is the first basically you can think of first point in which the data gets held on until the data is put onto the Vertica. And similarly, we have another mechanism called express load. This express load is basically depending upon the MinIO S3 mechanism. It internally uses the S3 buckets, and then it also holds the data until the data gets loaded onto the Vertica. So at a very high level, these two mechanisms of pulsar as well as express load holds the data until the data gets onboarded onto the Vertica. So along with this, when we are actually talking about, as soon as the data gets ingested, so we do provide mechanisms to process this data in two phases. One of the first phase is the preload. When I say preload, before even going into the Vertica database, if there is any transformation that needs to be performed, we do have the capability to put in certain kind of transformations, and then we'll talk about that further in detail actually in the preload processor. So post this preload processor, again the data gets streamed back into the Vertica. because the input and output of this preload processor is basically the message bus from the pulsar. Along with this, once the data get loaded into the loaded into the Vertica, we have the post-load processor. So as the name suggests, once the data is put onto the DB, we do provide a mechanism to run specific tasks so that the data which is there ingested, which has already been ingested and loaded into the DB, can be again processed. So that module which processes that is basically the post-load module, right? And once all this data is put in back into the Vertica, we do provide the capability to read the data which has been put through the data access APIs, and the suits use these data access API to access the data. Just to recollect again, right? So we do provide the various components within there are few multiple modules within the COSO, whichever you can see in various block diagrams. Once the data which gets loaded into the system, we do have mechanisms to hold it in the pulsar at the first level, and then express load, and then immediately once you load it through the various scheduling mechanism, this data gets loaded onto the Vertica. And similarly, we do provide the mechanism to pre-process as well as post-process the data. Along with this, when each of these components, multiple components are there, naturally, we multiple modules are also involved with the data flowing in different sequences. In order to identify and understand, or even to troubleshoot the status as well as the message ingestion, we do have the monitoring capability inbuilt, which can be used for identifying the Kubernetes states as well as the various data flow. For example, how actually the data is happening, data is flowing through the express load or through Pulsar, as well as the various dashboards which will give us the information about Vertica status, as well as the data which is getting streamed into the Vertica database. So with this, I think probably yeah, and also probably along with the data access, the regular SQL clients can also be connected to the Vertica, and then they can view the data which is get loaded, as well as to identify anything, any of the troubleshooting steps which they would like to perform. Right. So with that, I think I will just jump on to the next slide. This particular diagram actually shows in detail the flow, data flow, as well as the configuration flow, which we just now discussed. For example, the one which is there in orange indicates the data which flows through the various components, and then the green one indicates the configuration. The black lines indicate the flow of internal COSO events, or any configuration related information, any of the messaging which the COSO relies on to identify the various or to identify and also process various steps of data processing. So as I said, the one of the primary point is this admin server, through which we ingest the configuration information through using the REST APIs, and then post the configuration, we load the data using external data sources. These are primarily from the suits. They load the data in either the HTTPS receiver or directly into the Pulsar through Pulsar topics or through Express load. And this also gives you a deployment kind of an architecture, in which we have workers and then the master node which will control the workers, and then process the various data streams. We'll discuss each of these modules in detail in the upcoming slides. If there's any question at this stage, probably we can we can just visit for a few seconds, few minutes. Any questions?
Srinash, just to see that I understood. So data flow from the external data source, assuming that I'm using the receiver, the HTTP. No, stay in the same one.
Okay.
So it goes through the HTTP receiver. It goes through a topic to the pulsar broker. Then it might get a change by the preload processor. From there, it go to the pulsar proxy through the UDX mechanism to the vertica. And in the vertica, it might be touched by the post-load processor, right?
Right.
No, actually, to
Right.
an
That's
extent,
right.
you're correct, except the
That is
last
that is
one.
that is that is one of the possible flows.
Yes, one of the possible flows. I think let's go back to the previous flow. Here again, we can discuss, right? So the data which got ingested is basically loaded using any of these mechanisms like express load or through message bus. Even HTTP receiver, when it gets loaded, it pushes through it to the pulsar, and again the data gets loaded. So this is just a plain, as soon as the data comes in, a normal scenario in which the data will land in the into the Vertica database, right? But we do provide additional mechanism so that this data can be either pre-processed. So when you say pre-processed, it will not go to the Vertica database. It will be loaded from the pulsar topics, and again it gets transformed. Again, it will be put back to the
So the
message.
preload is actually grabbing the data from the topic and return it to the next topic or to the same topic.
Yes.
Yeah,
Yes.
correct.
Yes.
So
Yes.
Okay.
yes, it has a source as well as
Actually,
single.
actually, if you can wait just a bit, we detailed
Yeah.
the different
No,
flows.
no problem. No
Uh,
problem. Wait. I
yeah.
will wait. No
Yeah.
problem. Thanks.
Uh,
Thanks.
yeah,
And
I have a question here, please. How are you? For the Grafana, is it part? Why is it part of the architecture here? Grafana is our third part. It's a third party, right? Tool, almost like
so
yeah.
so it's like this. We have a, I mean, like as you know, all of these are, I mean, all of these services are in pods. So
Yeah.
Grafana, Prometheus, and all are some pods that we have, and this constitute the monitoring module. And so we have these exporters and all that, which sends the data to Prometheus, and it is reflected on the Grafana dashboards.
Okay.
So those dashboards, the user will be able to access externally and see what is the status of the flow for debugging, or like to see the health status and all that. So
Okay. Thank you.
So
it is
similarly,
not actually, it is not intrinsic to the flow per se. It is more like a debugging and health status tool that we have integrated into that whole thing.
Yeah. Okay. Thank you.
right? Like as Oni mentioned, even the express load, the Minayo bucket is also a third-party component similar to the Pulsar. So all of these third-party components, from the COSO perspective, we have wrapped around, and then each of them are available as individual parts. As well as we do support additional some of the capabilities, and but what it has actually done is it has wrapped around these third-party components and we have made them available as the Kubernetes parts. For example, this monitoring pod or even the Pulsar various parts.
Yeah. Thank you.
Right? Yes. Any other question? Okay. I think, yeah. Again, we can revisit. So I did cover a few parts of it, as I said, the administration service. This actually acts as an API gateway, and in order to provide the configuration information, which including the dataset information as well as source and destination dataset information, which the suits configures and puts it submits as an REST interface. Along with this, administration module also is responsible for providing the overall configuration information for individual components of the COSO. For example, it could be like the S3 bucket creation or the express load connector when actually it gets loaded or launched. Even for that matter, the post load and the preload interact with the administration module in order to identify the set of activities which they need to perform. And the metadata server is also pulls the configuration information from the administration service. So overall, administration service is the API gateway, and then also it acts as a orchestrator for the configuration information which gets flown through. And another module which we discussed was even this HTTP receiver. This HTTP receiver also provides is basically one of the mechanism which data can be ingested, ingest the JSON messages, or it could be a JSON array or a JSON message which gets ingested. And then it subsequently transfers that data to the various pulsar topics, depending upon some of the keys, key as well as the topic header information which it receives, right? And this is TLS mutually, TLS enabled between using the client CA. This preload again we'll touch upon. I think almost I covered the content in this slide. The idea of putting few of the content in the post architecture slides was so that you can revisit and try to recollect the information if needed as a reference material. So I'll just skip few of the tables. Again, we will few of the slides. We'll recover this in the upcoming slides. Yeah. So, but one thing probably I might not have covered is the need of the data access. For example, when somebody can directly query the DB, why we have provided the data access capability is basically to provide some kind of abstraction from the database, and then when I say even abstraction, we do provide some of the additional mechanisms so that, for example, we do have some kind of pagination in terms of how actually somebody can query the data, filter it out, and then use that for generating the reports or even the viewing capability, and integrate, and then provide some kind of a dashboards. So all those capabilities are available through these data access. It do remembers the COSOs, and then somebody can come back and query, and then query the data in multiple streams. This as I mentioned, the COSO Health Insight Dashboard provides the monitoring capability, not just for the data flow, as well as it also provides the capability to identify the status, as well as identify the resource consumption of the individual parts of our own. For example, it could be like a post load or data streaming, or even the administration service. You will be able to identify the resource consumption. But along with that, the main thing is probably if there is any issue in the data flow, we can look through this and try to identify until which module the data has flown, or and where it has stuck, if at all it is stuck. And then you can identify some of the troubleshooting mechanisms through which you will be able to see what might have created the real issue. Yeah, for example, looking at the logs, or even looking at the resource pattern. Is there any load which has ingested very newly and which has created the spikiness or higher thresholds of the resources? All those can be viewed. Okay. And we do provide multiple components are there. So obviously we do provide the multiple dashboards. Each of these, I think we will again further discuss in the upcoming slides. So this is a reference deployment of the COSO. Basically, this number of nodes which we have provided is just for reference. The individual suits do based on the loads of the data ingestion and the various requirements of the data access. They do configure the number of nodes based on the usage pattern and then the scalability needs. The one which I have shown you is a 4-node, actually is a 6-node at 6 node, but yeah, in the number of nodes which we have mentioned is around 4 nodes. This is just a reference, and as such, the COSO provides or has the various components like the bookkeeper, zookeeper, which basically are the pulsar components, which pulsar proxy and pulsar scheduler. As well as we have our own individual parts, administration, processor, and preload and post load, as well as the metadata related one. And even the self monitoring, as we have seen in overall architecture diagram, is also another part. And irrespective of this, the Vertica node is actually an external entity, is basically the external Vertica cluster through which the parts of the COSO interact and then either ingest the data, or they will access the data and then provide the various preload or postload transformations. Right. So that's about the deployment one, and then let's look at the configuration overview. So this is again the administration module. When actually the configuration REST clients, these are the suit specific clients, they will connect to administration through the REST API through a client, and administration service hosts a RESTful server for providing the configuration through it provides APIs through which one can configure the various data sets. Post that, it once the data gets once the API request comes in, it actually routes based on the request to either the post load processor, so that it can parallelly create the task controller and task executor based a chaining so that the task can be run as well as the data can be processed. Similarly, it pushes the data to metadata server, which is responsible for creating the data sets inside the database, and or it can even inform the express load storage server, and which basically starts consuming the messages or configures the it basically provides the configuration based to all these individual modules based on in summary, based on the API request which comes from the clients. Various module do interact with administration module, and then they configure the basic flow and get ready for the data which might come in the upcoming the suit requests, as well as it also connect and configures the Vertica as well. So that's about the configuration flow, individually how actually the configuration request flows. Next, let's look at the data flow overview. Here actually this is the module which processes the incoming data. We do provide three mechanisms. One is through HTTP receiver, as well as somebody can directly write it into the pulsar, right? So this is one, and we call them as the streaming data flow. Whereas the other one is there, the next one, which is basically based on the express load. One prime difference between these two is in case of streaming data flow, we do have the capability to pre-process the data. In case of express load, it directly gets loaded into the Vertica. But whereas the data which comes through either the HTTP receiver or the one which gets ingested directly into the pulsar has a capability to pre-process. Right? So that is one difference. Now, let's say let's look at how actually the data flows and what are the components which is involved in loading the data into the Vertica database. So the external data sources, basically the collectors, ingest the data to the HTTP receiver. And this receiver, based on the various topics which is already being created as a part of the configuration request, they writes that into specific topics. So the HTTP receiver push the data into the Pulsar broker. Pulsar broker basically keeps that message until it is been read by either the Vertica or by the preload based on the configuration which has been pipeline which has been set in. So once that so this basically you can assume, you can think that the Pulsar holds the initial data, because it actually is the one which provides the guaranteed message delivery until the data gets loaded into the Vertica database. And at the moment the data which has been written into the broker, anyone can be rest assured that data will be persisted. Probably and once, even if there is any issues, the data gets persisted. Post the system gets recovered, or immediately once the data has been taken for processing. And even if there is any issue in processing, still the message will be kept inside the Pulsar topics, because we do provide, we work on a publish subscriber mechanism. So until the subscriber fully reads the data and then push it into the Vertica database, it doesn't acknowledge the message for the particular topic. And due to this various the stateful flow of the message, once the data which has been pushed into the message bus, anyone can be rest assured that the data will be loaded onto the Vertica database, will be made available in the Vertica database.
What happened if the Pulsar broker is not available? The HTTPS receiver holds it, or is it
No,
ignoring
okay.
it?
Yeah, good question. Then the client itself will receive the information that it didn't the message ingestion has failed.
So the external data source need to wait to acknowledge that it was read by Pulsar.
No, the HTTP receiver will receive that message, and then it will forward that to the Pulsar.
Yeah, but if Pulsar is not available,
Yeah,
or
available, it will immediately respond it back. See, there is no
so it will respond to the external data source that the message was not sent, and now it's the responsibility of the external data source to do whatever it wants, to keep and resend it or to ignore it.
Yes,
correct.
yes,
Okay.
yes.
Okay,
It has to resend.
thanks.
Yes. Right. So okay. So once that data comes in, once the data comes in, the Pulsar provides the capability of holding the message. So like as I said, once the data has been loaded into the message bus, the clients can get assured that the data will be ultimately be loaded onto the Vertica database. Right. So along with this streaming data, Uh, and another path is also, they can directly write into the Pulsar proxy also. These two mechanisms are available so that the data can be pushed into the message bus. So post the data which has been loaded into the message bus, the next thing is how actually the data gets loaded into the Vertica database. So for this, we have developed a module called a Vertica streaming loader, which is known as a combo of a scheduler as well as a UDX component. A scheduler is a pod of the COSO, which basically plans the repetitive or schedules a repetitive or an iterative through an iterative mechanism to revisit all the topics within a time window, right? and then it basically runs something called as a copy command, which is basically a command which gets run on the Vertica cluster itself using the UDX command. So let me check whether the flow is there. So what actually what it does is the UDX the scheduler will keep scheduling for a given topic the copy commands, and internally we have developed a plugin component called as the Pulsar UDX extension, which is basically a module which will be loaded into the Vertica. And this module keeps based on the incoming copy command, connects to a specific pulsar topic, reads the data, reads the messages, and then it loads the data into the Vertica respective tables. In case of any eventual issue in loading the data, it basically rolls back the entire transaction. Right. So if it successfully loads the data, it informs the pulsar back saying there's basically an asynchronous information which it says that I was able to process so many messages, and the pulsar will drop those messages from its the list of messages which is there in the individual topic. So in order to let me try to recollect in summary what actually will happen. The external data source feeds the data into the HTTP receiver. The HTTP receiver pushes the messages into individual pulsar topics. Similarly, external data source can also feed the messages directly into pulsar topics also. So if both of these will be picked up by the UDX scheduler, and then in a periodic fashion, it revisits all the available topics, keeps pulling the messages, and then keeps loading the data into the Vertica into the respective tables. Once the data gets loaded, it acknowledges or informs the pulsar so that the pulsar uh, um, can move the cursor and delete those messages which has been consumed. That the importance of this is this will also serve as a cursor so that the new incoming messages can be loaded again in a is more like a window where in which the are released, where the messages will be keep coming in one part of the pipe, and in the other part of the pipe we read the data and load it into the Vertica.
Sorry, a question. Is there a mapping with respect to the high-level process collection we use to configure in COSO? So aging metric collection and metric streaming is exploiting different paths with respect to what you explained, or regardless of the flow? Is a difference?
Actually, whether metric streaming uses the receiver or whether it directly goes to pulsar proxy, I'm not sure. That is actually something that probably Rahul can cover in the next session.
Okay.
Here the answer. The agent metric collection is actually collecting and storing as CSV files using the CSV loader. Okay, and there is the other question is you can configure the agents to forward to HTTP receiver. Okay, that is the other path. So we have two ways.
Okay, so if you are using the CSV, I mean, whatever you are streaming to receiver, obviously that is the first flow that he showed. Yeah. And the ones that you are collecting as CSVs and placing, the currently supported one is the express load that he will be taking in the next, as part of the next flow.
Yeah, I have a question also for that part. Previously, there was a component called the CSV loader, but it was not many IO. That was coming with COSO, and many IO was introduced with NOM, as far as I remember. So I want just to understand, is many IO now will be used against any CSV file replacing the previous one? or
Yes,
it's
yes.
none?
Yes, 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 yes. It is that is so. Since 2011, that is the status, in the sense that, I mean, there is no longer that bulk load 1.0,
Yeah, bulk
we would
load,
call it.
yes.
Yeah,
Yes.
yeah. So yeah, that bulk load is not available. That bulk load version 2.0 is what express load is basically.
Okay, very good. Thank you very much.
Okay, so I think the express load is the follow-up slide, right? So this basically covers the pulsar streaming. So once the pulsar messages are loaded, the Vertica streaming loader will repetitively run the copy commands and loads the data into the respective tables, respective data sets, right? So with that, I think let's move on to the next ingestion mechanism. Okay. Along with this, let's also try to cover the dashboard. Basically, this we call the one we related to the Vertica streaming loader is basically the data flow overview. This gives you the information about all the pulsar components as well as the individual components of scheduler, for example, the scheduler related one, and the data processor related one. All these part information is also available. Along with this, per topic or at a very high level, also a overview dashboard of the streaming is available. That I think you can view it in the dashboard, right? So this can be used for identifying the status as well as any the flow where actually the data is being currently held up based on the various metrics which are available in the dashboard.
Okay. I have a question. You mentioned in the previous screens there is something called stateful and stateless messages. Yes. Can you tell us what are the difference between them?
Will you be able to cover that, Tony?
Sorry, I was on mute. Can you repeat that?
Yeah. During this slide, you mentioned something called stateless and stateful messages. Like for streaming, you have the option for stateful or stateless messages.
Okay, there is nothing like a stateful or stateless messages. This comes into picture in the preload actually, where maintaining state becomes more important. I mean, like otherwise, whatever you are streaming through, the bookkeeper bookkeeper and zookeeper together sort of ensure, bookkeeper is a storage and zookeeper sort of ensures the state maintenance. So inside the purely streaming flow, there is no I mean, nothing like stateless and stateful messages. Whatever you are sending through, so at any time if the say the pod is going down for whatever reason, like it's a I mean, consider disaster recovery scenario, someone where you're stopping it and all that, right? So the message state is maintained by the application in zookeeper. So when we go to streaming flow with preload, we would come to a set of I mean, there's something called window transformation and all that. There, these things may come into the picture. Otherwise, I am not clear about what else will come in as stateful and stateless.
Okay, no problem. Thank you.
Yeah, like as Uni said, there is no state of any of the messages in this particular streaming. And once the message which gets ingested into the system message bus, it will be consumed by the Vertica streaming, and then it gets loaded in sequence.
So basically, that acknowledgement and consumption is the only thing that basically is, I mean, what you can consider as state, I would guess. Nothing else otherwise.
Yeah.
And for the Pulsar proxy, we are sending, we can send data through like something that's supported with Pulsar, like Pulsar clients, something like that.
There is a Pulsar client, and I think you have it in both Java and Go. Anyway, so you can, I mean, I think typically Java client is used for that, right, Srinath?
Yeah, Java, C++, Go, C, C++, Go, All the different
Yeah, I
various
think
languages are there.
I
Even
think
curl
norm
also you
uses
can use.
right.
But
I think norm uses Java client for their loading. I am not really clear about what OPSB uses for. I mean, or in which case they use it.
No problem. Thank you very much.
Sorry about this question. I understand there is no difference in the events, stateful, stateless, etc. But with respect to the zookeeper, bookie, and broker, is there a difference in a way that those three processes are working with respect to this stateful or stateless, let me say, difference itself? Yeah.
Okay, as I mentioned earlier, there is no such difference as stateful or stateless. So any data that comes into the pulsar, okay, as far as pulsar, very basically is a message bus. Okay, so as far as the message bus is concerned, I mean it is concerned about producers and consumers and the ACK that you provide to them, that okay, this has been logged into pulsar and this has been taken out of pulsar. So there is something called TTL, which means once the message bus acknowledges that this has been consumed, that TTL usually like 1 hour. So within that time frame, that messages gets deleted from the message bus because it has been already been consumed and the TTL time period has crossed. But otherwise, Pulsar proxy is basically like a gateway into it, and from there bookkeeper sort of acts like the storage, and broker is again something that I mean like that we used for. It is a bit like
keeping the
proxy.
ledger.
Yeah.
Basically maintains a ledger, which is
Yeah.
basically the message which is getting
The interactions
sent.
with the different the interactions with the different producers and consumers, right? So that again I mean, I didn't want to make this a detailed technical overview of the pulsar, but I'm trying to make it very simplified, even though it is not exactly that. But zookeepers sorts of keep the state maintenance for the message bus. Broker sorts of keep the ledger and I mean all the acknowledgements and all that comes through the brokers. So you have this different topics and partitions and all that, and that comes in. And bookkeeper is where at the end of it the actual storage happens for the messages. And proxy, as I mentioned before, is like it's a proxy basically. So I mean when you interact with the different so I mean like when you're having when you're having multiple like Vertica is 3 node and you need to alternate between the different nodes. So that kind of thing, it's better to have a proxy in front of the broker rather than go have each broker connect to the different nodes and all that.
Okay. Yeah.
Okay.
I think so with that, I think let's move on to the express load.
Just a minute. So if I understood correctly, based on the TTL, so the guaranteed delivery is only if it's happened in 1 hour.
Not that is configurable. Currently, it is configured with 1 hour. Correct.
So if the Vertica is not taking the message from the bus for more than an hour, we will have a gap in the data in the Vertica.
Correct.
Yuval, this TTL after the message being consumed. Okay, so they receive the messages.
No. They assume that within 1 hour it will be consumed. This is what I understood from the explanation.
Correct. So within here the point that what actually Alexi you are trying to cover is this pulsar provides a more like a message caching until the TTL gets kicked in. Based on the TTL can be configured. Currently it is configured with 60 minutes, meaning until 60 minutes it provides you the guarantee that message it will provide you in ordered or sequenced message delivery. Post that, right, it will not be able to provide the message delivery. The reason being, if the incoming rate is high, or if the proxy, if any of the broker or the bookkeeper goes down, all those things, if it all happens, then it will not be able to provide, because as a part of the recovery, it might try to clean up the messages which is not which has crossed the TTL. The TTL is configurable, so that how actually individual based on the available storage that gets configured.
But again, to point out one thing, I mean, like this is streaming. 1 hour is too much. We don't expect us to get anywhere near that.
Yes.
Yeah.
In a normal scenario, what we have seen is within 1.5 minutes in the current observation, 1.5 to typically around 6 minutes, maximum is 6 minutes. In case if there is any eventual issue, we have seen that the data gets loaded in the current internal testing which we have.
So if the UDX is acknowledging, or the preload is acknowledging the message, it will not wait for 1 hour. It simply be deleted once it's been acknowledged.
Yes, once the acknowledgement comes in, it will be deleted.
So the first between the acknowledgement and the TTL will remove it. The first one between them.
No,
Yes.
see, within 1 hour, if you don't acknowledge, the problem is,
Yeah,
the
but if
storage
you
will not
acknowledge,
pick up.
if you acknowledge after 2 minutes, the message will be removed after that 2 minutes.
Yes, correct.
Okay.
Okay, just to add one more thing there, it's not exactly 2 minutes. So it is scheduled for deletion. It is like there's a small time period after which, I mean, like it's not immediately deleted. I mean, like there's a small time period,
It will be
right, Srinath?
correct. It will be an
Will be
internal
marked
state,
for deletion.
marked for deletion. When I say mark for deletion, what actually really it happens is, in terms of Pulsar terminology, it is not responsible for guaranteed delivery post we acknowledge.
Okay.
Okay, so it will provide you the guarantee until the message gets acknowledged.
Okay. Thank you.
Okay, so I think let's get on to the express load.
Shrina, one more question about the data flow in the Pulsar bus. You talked about a time or a window in which is used by the broker or the bookkeeper, don't know exactly, where the data items are bulked up before they are transferred over to Vertica. So this behavior has an influence on the data availability in Vertica. Means how long does it take when a data is arriving until it is in the table for further consumption? Is this a time-based window, or is this an amount-based window?
This is not a time-based window. Basically, it is like, I mean, it is more of like, how do I put it? Okay, first of all, the end-to-end time frame, like Srinath mentioned, is usually like, I mean, the 90th percentile I think we see is around 1.5 minutes, which means from the time the external data source pushed it to the time it has reached the Vertica. Okay, so that end-to-end time, 90th percentile we have seen is 1.5 minutes. Now, coming to this particular thing, it is we have something called frames, and see, without going too technical, it's basically like the UDX is actually like a consumer for the Pulsar, and it sort of schedules the frequency at which you pull the data. So that Vertica streaming loader that you see there, right? So that sort of does that and ensures that we are having micro batches at not too big a frequency nor too low a frequency.
Mm-hmm. Is this a dynamic frequency, or is this something that is configurable?
It is configurable. It is basically a configurable one. Based on the needs of the suits, they do configure, from 30 seconds to based on their, until 2 minutes or 5 minutes. It is configurable.
It is configurable,
but it's not configurable with the deployment by a customer, right?
Yes,
depending upon the
it's
load.
actually configurable at deployment time, and if the suits feel that as per the difference in load profile, it needs to be changed, the suits will be exposing this as a configurable parameter. Right now, I don't think. Yeah, right now I don't think they have exposed it as a configurable parameter.
The end customer, they might not.
The lower you make that frequency, the more performant the whole thing is. But the higher the frequencies, the more up to date the data is, the more you get a real time behavior.
Yeah, so it's like this: the lower the frequency, the more as you said, the more stable the performance is. But at a higher frequency, even though it's up to date, it is not ideal for. I mean, beyond the point, it's not ideal for a Vertica kind of database. Yeah.
See,
so whatever we came up with is like a, I mean, like the optimal one for the kind of loads currently that suits have.
Okay, but once again, this is a fixed value per suite or per data injection, right?
It is for a profile. I think the suits have identified their ideal numbers, and I think sort of like that. It is not currently exposed, nor I don't think the suits currently. I mean, the suits are better placed to explain it, but I think they don't currently plan to expose this to the end customer. Is my understanding.
Okay, thank you.
So just to give you a few more pointers on that, right? It basically acts as a frame window. We call that as window, which is basically a time slice which is further time sliced into multiple topics. And each of the topics we go in a democratic way that we provide an equal number of loading capability, and we pull the data and it gets loaded. If at all there is any saving, we'll also try to optimize. That is some internal one. But point that you need to really remember is there is a frame window, and it basically it tries to provide an optimized mechanism so that all the topics it will keep visiting every within that frame, and then it keeps loading the data as much as possible, right? Based on the load, the incoming data, traffic, and other things, the suits will further fine tune, and then they will provide you the if at all if there is any configuration based on the support and other things, they will be able to help you out, right? So it is basically a repetitive job which the UDX runs very often, and then once the data is there, it will load it into the respective tables, right? If there is any further question, probably we can take it towards the end. Let's go into the express load. So even in case of the express load, the data which comes in is basically, let me see whether the flow comes in. Unfortunately, 1 second.
I think if you press enter, it should come.
Okay, sorry. Okay, so the external data source, which is basically again the suits, will ingest the data into the express load storage server. So as a part of the configuration, express load buckets and other things gets basically the pipeline gets laid out, and post that the external data source loads the data into the express load storage server, which is nothing but placing the CSV files and then invoking the express load API, informing about the available file, and then the express load basically express load connector pulls the message from the S3 MinIO bucket, and then it pushes it. Sorry for the correction here. I think MinIO should come, not the Pulsar one. But the express load, that's correct.
Sorry,
right?
no. Actually, it's like this. Express load connect, like the Pulsar UDX, which sits inside the Vertica cluster. Express load connector, which sits inside the message bus, triggers a copy command in Vertica cluster, and Vertica pulls the data from the storage server. As in the case of Pulsar UDX, it's a copy command execution, and Vertica pulls it from. In case of the Pulsar, the streaming flow, the UDX that triggers the copy command makes sure that data gets pulled from the Pulsar topic. Here, a similar copy command pulls data from the storage server. And like the streaming loader you saw earlier, the express load connector is the equivalent scheduler here.
Yeah, this is a scheduler, and then it keeps scheduling based on the incoming request. The express load storage server, the Vertica will pull the data and push it into the respective, loads the data into respective tables. And also, in order to know the data, we have something called as history tables for both express load as well as the streaming load, in which you can identify the data which is ingested or loaded into the historical data also can be seen.
Excuse me, the data sources here for the express load can be what type of data sources are acceptable here?
So so it doesn't matter to the express load what the data source is.
Okay.
It expects the so basically this express load storage server is as he told, it's the underlying technology is Minnayo basically, which is so basically it expects S3 compliant API calls to be made to it, and if it can be CSV or gzip. And based on there is a separate API call for both that you have to make. In case of gzip, you have to mention the type as object type as gzip, and this thing is different, so slightly different but same call, so that way you get the data loaded to the express load storage server as S3 objects, and it lies there waiting for the copy command to be executed. And express load connector, as I told you, it schedules the copy commands. It also keeps a track of what is getting loaded in the storage server, so that that's like a heartbeat thing. It basically ensures that okay, the bucket is clean. That is what it tries to do.
Am I right to assume? Am I right to assume that this express load feature is for mass operations like data
Yes,
coming from RAM and from NetFlow and so on?
I'm not aware of NetFlow, but I think RAM is one of the use cases that was discussed.
Yeah, I think NetFlow, the traffic data in NOM would be equivalent. Yeah.
Can I say something here, that the difference between this one and the bulk loader, the previous one, that this now is offloading Pulsar from the CSV data, because you said like it's copying directly to Vertica.
Yes.
So that's actually how we added more capacity to COSO to support this enormous number of files.
Yeah.
Right?
So actually, as you told earlier, bulk load earlier, even though the volume wise both would be same, this way you are sort of speeding it up a bit more, and the data does not have to flow through. Actually, earlier also data would not be flowing through, but your whole scheduling, if you compare the earlier bulk load 1.0 and the current express load, which is bulk load 2.0, the difference is primarily that the scheduling has been made much simpler because of this, the introduction of the Minnayo component. Earlier, that whole scheduling was done inside our post load process, which we'll be taking later. So that was slightly different, and it did not really fit the post load processing criteria also. So it was better that we moved it out as a separate thing. That was another reason.
Previously, it was mapped to topic. Whatever you collect as a CSV, it's uploaded first to a topic, and then from the topic to the database.
No. It was managed from Pulsar, but it was not getting uploaded to Pulsar. I think that is a misunderstanding that is there, but it was not getting uploaded to Pulsar. The earlier bulk load still was basically in earlier bulk load. Our
it was Kafka at that time, but it was in the configuration. There was a topic that was made for everyone.
Yeah. So that topic again. That topic is like metadata management. So the actual execution was still directly from the CSV in the NFS into the Vertica. That was what was happening.
Nice, very good. Thank you.
Okay, so similar to any of the other parts, we do have the health indicators through which you can identify the resource consumption as well as the message which is getting ingested. I think with this, I think we were able to foresee that the data has been already loaded into the database. So post that are okay. The preload is before actually getting loaded, and then post is after the data gets loaded, right? So in case of preload processing, it basically provides a transformation capability so that the data which is getting ingested can be transformed and again routed back into the pulsar topics. So to provide this kind of a capability, let's look at one of the example. Is it the next slide? Yeah. So in this slide, as you can see, how actually the transformation can happen. We lay down a pipeline. A definition of a pipeline saying that this will be the pulsar source, which is nothing but one more topic from which we'll collect the data and then we'll perform the transformation and then again push it into the another topic. This is just a simple three node or three module transformation source and then transform and then sync. So with this kind of a pipeline, the data which is getting ingested can be processed, pre-processed, and again routed back into the respective target topic, and again the data will be again pulled from the streaming interfaces and then it gets pushed into the respective data stores. One of the example is event analytics, which has provided this kind of a custom pipeline for event correlation. It processes the event, correlates them, and then again, based on the need, it will again push it back into the post processing, push it back into another pulsar sync topic. So this particular diagram shows how actually the data gets flown from the preload.
Just press enter. That's it.
Yeah. So like all of us already know that the data which has been coming through the HTTP receiver will be pushed into the pulsar broker. So from the pulsar broker, based on the pipeline which has been defined, it will be pulled by the preload processor master, and then it will be provided to the worker. This job submitter is nothing but the definition of the pipeline which gets laid down, and once the data is available, it will be pulled by the workers, and then it gets processed, and then again it will be pushed back into the same pulsar. So this is the extension of the previous slide. Here acting as a source and sink, and then processing as a multiple worker nodes, right?
Just to add something here, this applies not only to what is coming through HTTPS receiver. Even if data came in through Pulsar proxy and reached the bookkeeper, that same will be available through the broker for us to pull. So, I mean, it doesn't matter whether the data came in through the receiver or the proxy. It should not matter for the preload processor.
It basically gets from the topic, one of the pulse topic, process, and then it will again push it back.
Just that the pulling point is broker, that's all.
Yeah.
So basically what you showed earlier in the slide, that you have a source and the time slice and the thing, this is a topic. And you can modify the topic.
Modify the data, not the...
Modify the data in the topic.
No, the flow of the topic. Because if you are not enabling the event, the EAC, so you won't go to the worker, for example.
Right. So it's basically like this. If so basically the data that has come in and the data that is going to the the Vertica should be in different topics. Otherwise, I mean, like it would be going straight through. That's another flow that is possible without going through this, right? So, that's why, I mean, like the incoming, if you are having preload, the topic that you are posting to from the data, so from the your external data source would be different from the expected one for the pickup for the Vertica.
Basically, when an external data source send the data to a topic, for example, public default scope global, something in Pulsar move it from this topic to a similar topic, but one that vertical reads it.
No. I mean, like nothing in Pulsar does that. I mean, like the source topic from which, so basically the data source that is pumping it, right? It pumps into that particular topic. So you have both the topics there. Like, okay, just to give a rough example, you have a say input topic, say I, and output topic O. Okay, so if I mean, like the Vertica, the UDX would be listening for output topic O to pull data from, and
so
when you
every
are
square here is a topic.
Sorry.
Every square is a topic. There is a topic called Pulsar source and Pulsar sync.
No. Pulsar source is from one topic. Pulsar sync is from is to another topic, and the timestamp transformation, or like, I mean, it's an example basically, but basically the transformation that you should that you see in between is usually a jar. Okay, it can be out of the box that we provide, like timestamp or moving average. It can be a custom, like in the case of event analytics. Okay.
Okay. So the Pulsar source is a topic. The Pulsar sync is a topic, and the way the data is moving from the source to the sync is based on the definition. The definition of something that was created in the admin REST API using this JSON file that you wrote here, the pipeline.
Right, and also it's like we place something called pipeline JSONs. So that is how that configuration has been. Can you just go to the next slide, Srinath? Yeah, here. So here actually, if you here if you see that preload processor at the top. It basically the preload processor is using Flink engine as the underlying transformation engine. Okay, and when we say the worker is picking up from the message bus, basically that the worker is listening to this particular topic, and there's a Pulsar Flink connector. That's a basic component that does that integration, and using that we the Flink worker is listening to a topic, the input topic that we just discussed about, and it pulls data from there, and inside the Flink, which is the worker, you are doing the transformation that we had provided in the definition. And after the transformation, the output is provided to the output topic, or whatever I mentioned earlier, that is different. Now, how does Flink know what is the pipeline that it's following? So the job submitter, when it does that, we are actually providing the pipeline JSONs as part of our configurations. And as part of the configuration, we will say, okay, there's a pipeline like this, which will take from I and give out to O and use transformation T. It may be, as I told, it can be a custom transformation jar. It can be out of the box bundled jar. And that is how that the platform will know what to do on an incoming message.
Yeah, so theoretically, if we're going, yeah, go ahead.
Yuval, I'll tell you. Okay, simply the situation is if you are sending data with a timestamp that is not supported with Vertica. Okay, you have an application sending data that is not supported in Vertica. So what we do, we add a preload action
to convert this data to the right format. So we read from the normal topic that received the data, and we put it into another topic, then that topic will be loaded to vertical. Similar to this, we have another situation where we have topic. 1 second. Yeah, we collect if we collect data, for example, from agents and the site scope, and we want to store both on the right place on one topic shared between them, then we can do that. But this is not actually what we use this situation. We have also in preload. Yeah, if you want to enrich data, for example, if you are reading a location IP address, for example, and you want to add this IP address is located to which site, then you can do this in the preload. The actual functionality that was there before is called threshold, dynamic thresholding. So, for example, when I receive actual value now from CPU, I want to generate alert saying that this CPU is more than the standard value.
Yeah.
Okay. So I can do that before saving the data to the database through this preload.
Okay.
Correct.
These are all cases, and it can be more than that.
Yeah.
In summary, what actually we are trying to provide you is a capability to read the data, which is before even getting onto the Vertica, and then provide the conversation, a pluggable mechanism so that you can convert the data. It could be like filtering, or even it could be transforming the data from one format to the other, and various capabilities, and then again pushing it back into the Pulsar topic, right? And post that the data gets flown in similar to the normal Pulsar mechanism, because this is also another topic. The Vertica, the UDX scheduler will read the data and load it into respective target tables. So this is more like a hook which somebody can tap in and then process it. They can feed it back into another topic.
Yeah,
and
right?
and
a question
just,
here.
just one thing. So, like whatever Mahmoud was saying is actually related to the symbol transformations, which means like I mean, like for each record, this is applicable. You also have something called window transformations, which is like, I mean, for a particular set of records, you are having it in a window, and the output is based on that, which means the input and output need not tally, which means like you're sending in 10 records, and when you see the database, you may see only one record. Why that happened? Because it probably went in through a window transformation. So if you have window transformations like that, like moving average or something, that also will accordingly change it. So even that is supported. Just putting it out there. Yeah, man.
And that is what is implemented in AAC. When we receive more events, we process them, and then we can decide if they are correlated or not. Okay.
Yeah.
My question here, you mentioned that it's you have a jar file that can do this calculations. Okay, and you have something out of the box, similar to what you mentioned, but previously there was Perl supportability. Is it still there?
It is still there, and that is exactly what we will be going to next. So the difference here is that Perl supportability is inside the DB. Okay. It is for that is for data that has already reached Vertica. So that's why we call it post-load processing. This is preload processing, which means data has not yet reached Vertica.
So can you go back for the previous slide where you show the source and the sink? So basically, again, the source and the sink are topics, and the timestamp transformation or whatever you put in the middle, it's a jar that register as a reader to the source and a writer thing.
Okay, not exactly, because I mean that reader and writer that you are talking about is the thing, is the pulsar source and pulsar sink. So as I mentioned, this is basically Flink that we are using underneath, and Flink, yeah, like you would be aware, it's already like, I mean, like you have operators and slots there in a pipeline. If I look at it from a Flink perspective, this is a Flink pipeline I'm actually talking about. So Flink, you have like a source operator and whatever intermediary operators you have, and finally you have a sink operator. Okay, in this case, that source operator is the reader that you're talking about, and the sink the sink operator is the writer that you're talking about.
Yeah.
The
Fully understood.
the transformation, the transformation operator has no clue that it's dealing with data that is picked up from pulsar. It just knows it's streaming data. That's it.
Okay, thanks.
Okay. Also, I want to mention here to everyone that what you are seeing, like preload, postload, these capabilities are actually why we call this as a data lake. These are components of data lake, and we use it as a generic platform for all our suites. Okay, so that's why the team here is explaining every component. Yeah, we are pre-sales. I know I might not use this stuff, but these are just like additional proofs how this can support enormous data ingestion, how it can do some processing before and after, because these are questions that may be asked during RFPs. Okay, do you have this capability? Can we do this? Can we do that? So that's why we need all these details in this training to be able to understand customer questions about data lakes and stuff like that. Okay.
Yeah, a very valid input. Yeah, I think that's the reason. I think when we started itself, we started saying that this is a COSO platform. How actually we have developing each of them is to keep it as much generic as possible, so that the suits are, it could be pluggable easily, even by writing any additional wrappers, even from the field also. Right. So if you know all of these, probably it can definitely help you in providing any kind of newer capabilities, develop any kind of POCs and things like that. Yeah, thanks.
Just a question, just to finish up this. Each and every phase, source, transformation, and sink, is also registered in the storage. So each phase is writing the data in the persistent volume through the PVC, or just the source and then sink is taking.
So you have Flink has this concept of checkpoints and save points. Okay, I'll summarize it this way. So basically, you have this thing like, Flink is you have this stateful support, which means it. Just like Pulsar, here also you have support for state, in the sense that if in Pulsar we were talking about acknowledgements, like whether a particular message has been acknowledged, whether it is marked for deletion like that and all that, or whether it has been acknowledged as come in like that, you do that in the Pulsar side. Here it is like for every operator, you have this frequency at which, like if I remember right, every 1 minute or so we take a checkpoint, which takes cognizance of what operator is having which messages and all that. So theoretically, if you shut down our preload processor gracefully and you come back up, you would be able to continue from where you were earlier, and that data will not be lost. Okay, so that is regarding the state support for preload processing.
Yeah, to answer this part to Vincenzo, all the data is actually stored in disk, in the disk. NFS, but in specifically in the topics, they are stored locally to the workers. They are not stored in the NFS. They have local persistent store where these bookkeepers are linked to. So the data are not doing like this much traffic over the network. They are more into the workers machine itself.
Yeah, so it is exploiting the persistent volume claim. basically.
Yes, but it's connected to the local machine, not to the NFS.
Yeah.
That is a difference,
Yeah,
which
yeah,
is
yeah.
much faster and less traffic on the network. That is
Yeah.
what we have in Pulsar. Yeah.
Perfect.
And just one more thing, I mean, as I mentioned, this is about, I mean, specifically the preload processor does not store any data per se. It only stores the metadata, which is like the checkpoint that I was talking about, state maintenance and all that, right? It's about the metadata only. And so basically, once the data has come in and once it has gone out, there is no further storage for that particular thing. That moment itself, it is, I mean, at the next checkpoint, it's cleared. Whatever statement for that particular data we had done, it is cleared. And all this is on the NFS that we do. And the pipeline where we are placing it, that part I mean, I think it is still on the NFS only where you place it, and then it gets picked up for this. Like if you want to change a pipeline or put a new pipeline.
Yeah.
I'm just trying to kind of look at it as a black box for a reason, because most of the customer questions will be, can I ingest this data? Can I basically they have a third party, they have some sort of a data. So is there a kind of explanation on exactly what data can be ingested? You mentioned two types of files that basically can be ingested into this, let's say, black box to be eventually put in Vertica.
I would put it this way. I don't think currently COSO is exposed for consumption directly by end customers. That is my understanding. The PMs are better placed to explain that. The understanding is that currently data consumption would be through the suites, like, I mean, be it OPSB, be it NOM, be it DCA. But they would provide those endpoints where you can configure, because it is not a click and I mean, a very UI friendly click and configure thing. And also even you have to understand that the data that comes in has a definite cost when it comes to performance. The suites have done the required testing for that, including coax, and which is why we are saying that if you use this, it's okay. This is the sizing you have to use. So yeah. So I don't. I think that is the reason why, even though technically in a long run we can think of it, but currently we are not exposing it, I would say.
Okay.
Yeah. So we are developing all of these as generic components, but the end usage of it probably is right now available to the suits. And directly, if you are planning to ingest anything, you need to wait. Probably the PMs has to take a call and then make it available.
Okay. Thank you.
So with that, I think let's move on because even the time check, I was just checking, probably almost I have taken 20 minutes more from the overall presentation. I hope it was, informative. Let's keep moving fast so that, we can give the time to the OPSB suits also. So this is the preload dashboard, which gives us the information about the consumption and then further related to the message consumption rate also, right? Next, along with the similar to the preload, we have the post-load engine. There was a question related to the Perl tasks and other things. So here, actually, the post-load processing helps us to provide the capability to post loading the data, provide any kind of summarization or any kind of capability to forecast the data, work on building a forecasting information, or even develop some kind of a custom tasks using the Perl as a scripting mechanism. So the post-load processing engine also has the capability to run parallel tasks to an extent. Once you, it basically is nothing but again a pipeline. We call them as task flows and tasks. A task flow is nothing but a set of tasks. Each of the tasks is nothing but a individual individual Perl script kind of a mechanism, which again process the loaded data. It connects to the DB it runs the respective SQLs or commands on the data which has been already loaded in the Vertica, and then provides the transformation. So for this, we have something called as aggregate, forecast, as well as we support 3 different kinds of task types. One is aggregation, which is basically providing the summarization, then forecasting on the existing data, look at the futuristic on the historic data, look at the future data, and then also the parallel tasks, which is basically meant for building a custom tasks. So just a high level architecture of this, how actually it works. The suite content service providers basically provide the task flow configuration to the administration pod, and this administration pod internally contacts the post load engine, which is basically has a master as well as the worker nodes, and through the internal it again uses a pulsar to provide the status information of individual task runs and things like that, and it runs in a periodic fashion in a repetitive manner the aggregate or the forecasting data transformation, and then it loads the data back into the respective destination. For example, here what we have shown is the initial configuration in green color. The suite will provide the configuration, and then the data flow is actually nothing but from the Vertica inside the Vertica to the destination table. Meaning we don't load this data into the we don't bring that back into the post load engine. The post load engine connects as a client and then runs the commands on the Vertica itself, and then provides the transformation. So at the end of it, each of the tasks, you will be able to see an aggregated or a forecasted or a transformed data on the destination table. So this is again, repetitively it does, because the summarization need to be done based on the incoming data. So so it does these kind of activities as such.
Just a small detail that transformation shown inside the DB is very simplistic. It's actually a bit more convoluted than that. It is not very straightforward because we had to keep a track of what was already loaded, and we sort of do batching and all that. So I mean, this is a high level thing saying that from the source to destination we do it, but there are a lot of intermediary steps there. In case someone is thinking whether, I mean, it's a very simple
it is a simple transformation. It is not. Yeah. So yeah, but point what we are actually trying to say is it is done more on the Vertica DB itself. The post load engine acts as a scheduler and facilitating the repetitive tasks that needs to be run. It keeps track of the task which is running, as well as the information of the current status of each of the tasks. Right. So this talks about the post load, and even for this post load also we have provided the dashboard. The task executor is nothing but actually the worker. It has a master and a worker, which basically works with schedules, and then the other workers will keep working on fulfilling the tasks. That is about the data loading as well as post-processing and pre-processing modules. The last thing what we need to cover is on the data extraction flow. Like I mentioned earlier, we do provide the capability to read the data through the data access layer. Through the data access REST clients, somebody can connect and then request for the data. So once the request comes in, it contacts the metadata server, validates the incoming request, and then contacts the metadata server. And through the metadata server, it goes to the Vertica cluster, pulls up the data, and then it again comes back to the data access, returns back, and the data will be returned back to the REST client. Similarly, somebody can connect to SQL client also, and then they can either view the data or extract the data. The only thing is through the data access API, it provides certain advantages. In which one of the thing is the data abstraction. layer, and also the viewing capability in terms of how actually the data can be viewed in multiple pages and things like that, it provides, so that the reporting or the dashboards can make use of the data. I think even it provides some kind of summarization also, Uni, correct?
Yeah, so that's a, I mean, but more than the summarization, the thing that is of use usually is that in case because of some reason you need to change the name of a column or a table, because of the way it is abstracted, like we have something called IDs, like configuration IDs that you provide. So the configuration ID does not change. It is just the table name that has changed. If you are using a SQL client, then when the table name and column name changes, your query has to change accordingly. But in this case, that change is automatically handled by the data access and metadata server. And also the batching is also sort of, I mean, like, at least part of it is handled by data access. We haven't gone too much load heavy on this currently because it has not been, I mean, like, I think that kind of use has not come up till now. But yeah, I mean, and so the it sort of makes ensures that the amount of maintenance you have to work on the clients like PD or whoever is using them, that maintenance is less even when the names of the columns or tables changes. That is one primary thing that we usually hear.
Thanks, Uni. I think with that, we are entering into the Q&A session.
Yeah, can I add something on the previous screen, please?
Go ahead. Yes, please.
Yes. The data access SQL clients are like BVD is accessing COSO through the SQL clients, and bring your own business intelligence tool is also they are also connecting through SQL. And the data access REST clients are like performance dashboard in OPSB. When you change the source to be COSO, in that case, it's actually accessing through the REST API. And we have also in NOM, the performance troubleshooting interface. When it's connected to COSO, it's connecting to COSO through this data access REST API. So this is the actual implementations for this flow.
Yeah.
Okay.
Thanks.
That's what.
With that, I think we almost finished the introduction to the COSO. Hope it was informative, and let us know if you have any further questions.
Yes.
Yes.
How do I know what are the topics that need to be in the environment and whether they are functioning correctly? I assume through the monitoring dashboard. But how do I know that I do have all the topics that are required?
So actually, if you're, I mean, like from the suite perspective, if you're using it, I think the calls that you make, the configuration, first of all, the configuration calls that you make, they ensures that the required, when you say a particular data set is created, like not only the table, there are corresponding topics are also created. Okay, and it is just a matter of when you are pumping in from the external data source to the message bus. Okay, that is the only point where you have to look which topic you are pumping into. And I mean, like in case you are pumping through the through what the suite already provides, right? I mean, the agent collection and all that, I think those parts are already taken care by the collect ones part of it, I would think.
So my
you don't
question,
have to,
how do I verify? I need for example, to do troubleshooting. I know we're going to have it probably 2 days from now. But how can I know all the name of the topics that need to be deployed on the system? Is it written somewhere?
see, actually,
Yeah,
yeah.
Go ahead.
Yeah, I mean, basically, if you want to get to the technical hands down, there is a, I mean, you can log into the Pulsar and in the Pulsar pod, and there are some Pulsar commands. I think there was a L500 session that we had given earlier where we detailed all those things. I mean, what are the commands that you can to list the topics, and the topic names and the dataset names would be matching. So it would be easy for you to identify if something is missing or not. So,
and just to add to the Winnie's point, right? Even our COSO dashboard also provides you the capability to view the individual topic information. Let me see if there is any slide.
No, I think it is there earlier. I mean, right after streaming, right? Go up to the
stream. Yeah, I know that in the item DI monitoring, I can see the status of all the topics. The question is, how do I know the list of all the topics that need to be in the system? Because whatever is here, it's whatever deployed. I'm looking for what is missing.
Yeah. Can I answer this one, please? Okay. Simply, every content, we have a content block that is automatically loaded during, let's say, Ops Bridge installation. Okay, this content back is on something called content server. Okay, content and configuration server, or pod, we can say that. There is a tool that you can list the contents, and you can download them as a zip file, and then you can extract them, and you can see what are the commands that were initiated to COSO to create all the topics, to create all the tables and everything. So if you want to reverse this process, you need to export the content and then extract it, and then you will have folders. Folder for the tables, folder for the preload and post-load. If you open each folder, you will see a JSON file that is describing what should be created in that specific stage. And these files, all of them, are sent to the administration service by this content administration. And the administration service, they take these files and process it and create the right table or the right topic or the right post load and preload configuration. So that is the flow if you want.
Yeah.
Okay.
Thanks.
Most welcome.
And I think this part is covered in the next session by Rahul.
Yeah, correct.
Good.
Yeah, any other question? I think.
Yes, I have a question.
Yeah.
I saw that you changed content administration pod from with the last patch, and now the pod is OPSB content management.
Again, that's for the next session actually, because this is just the platform. Yeah.
Okay. Because I just want to know what is the difference between the two pods, and do we talk about the custom metrics?
Again, that is the next session.
Okay. And actually, what has happened is we have overshoot the time. Right, Alexei? I think it should be fine. Probably you will be able to accommodate. But the entire 2-hour session we took over only for the COSO.
Okay. Yeah, no problem.
Yeah.
Thank you.
So basically, from the content side, so as I mean, wherever you're seeing like configuration REST clients and all that, right? That is where Rahul's session will come into picture. That is the CAS and whatever that you are talking about. And to be fair, COSO is really agnostic of like what is the data flowing through. I mean, whether it is norm data flowing through COSO or OPSB data flowing through, COSO doesn't really know that. And that actually will be coming from the content administration side, be it in norm, be it in OPSB. So they can provide you the details for that, because we really are not too much aware of it.
Okay. Any other question?
If not, I think we can hand over to Rahul.
Yes. Rahul,
right.
you're there?
Hi, all. Yeah, I'm there. I'll share my screen. Please let me know when it's visible. In the interest of time, I guess we can keep all the questions for the end.
So guys, don't worry about the time. You're giving here gold, and we would really like to use the opportunity to have this kind of conversation with you. So if it's fine with you, you can push further than the time slot, and we will just thank you.
So I think with this, I think we covered the COSO session, and I'll hand it over to for the OPSB team so that they can cover their content. Thank you. Do get us, if there is any question, do let us know. We'll be happy to answer.
Yeah, you can post in the chat and we will answer that.
Yes, thank you. Bye.
Yeah, Rahul, you can take over.
Sure. Is my screen visible?
Yes.
Right. So I'll be covering the data consumption theory, the second part of it. With me, there's Bhupen, Joby, and Krishna. So I'll start off with the agenda. So here, this is going to be a short session. So I'll be covering these things. So first, I'll be talking about the data collection as to what are the sources we have in OPSB, and then I'll go into the OPSB tables, a bit on the terminologies, and I'll drill down into a few of our tables. Then I'll describe the content structure that we have, and then a brief on the custom metric ingestion tools if you want to create your own content. Then a bit on the CAS-CLI. So I saw one of the questions was there, a bit on that. Then the overview of the reports that we ship out of the box. And then finally, customizing our reports and a few best practices you can follow when you're customizing. Okay, so I'll get to the data collection part. So here you can see this was the diagram which was covered in the previous session too. So there's no express code because we don't use it. These are the few sources from which we get our data. So going into the system infrastructure, we have two sources, agent and site scope. In agent, again, we have two ways of getting data. So the first one is the agent metric collector, and this pushes data directly to the Pulsar proxy. Then we have the agent metric streaming, which puts data into the HTTPS receiver. Coming to Sitescope, the data from Sitescope goes directly into the HTTPS receiver. So this was the system infrastructure. For events, the data goes into the HTTPS receiver. The topology data goes into the Pulsar proxy. The synthetic transactions, the BPM data, this goes into the HTTPS receiver. And finally, the real user monitoring data RUM also goes into the HTTP receiver. So this was just a brief on the where the data comes to. Moving on, I'll talk a bit about our OPSB table. So in the previous session, there was a bit on the raw and the aggregate tables. So raw tables is where the data from the sources goes into, or the copied data from raw tables. We use the same terminology. So the collection frequency depends on what you configure it to. Coming to aggregation, there are two ways aggregations can happen. We have COSO standard aggregation. The hourly aggregations happen 5 times an hour, and daily aggregations happen 5 times a day. We have custom aggregations where you can customize the aggregation frequency. COSO provides for forecast, so you can specify your forecast rule, and you can get some forecast on the data you have in your tables. So we have DTT and FP, the forecast point type of forecast. Finally, retention just tells you how long you want to keep your data in your DB. So I'll just drill down into two of our tables. So the first one being the system infrastructure table. So like you can see this clear distinction. So we have the agent tables, which carries the data from agent. That is, it could be agent metric collector, or it could be the agent metric streaming. And then we have the agent list tables, which is used to refer to the Sitescope data. So the first table we have here, so you can see these are the same thing. So when I refer to them, it's just the type of the source that varies. The description doesn't change much. So the node table carries your node level information. So it's like high level information on your CPU, your memory, your disk, a bit on the network part. When you go into the CPU tables, this is more like the core level information of your CPU. When it comes to NetIF, it's per network interface, the information that is needed. The file system tables give you data of your file system per directories, like based on your directory names. And finally, disk data gives you the core information when it comes to the disk. In Sitescope, we further have a generic table which gives you information on all your monitors. This is a bit of a different table when you look at the other tables. So here we have like a mapping between your metric name and the metric value. So here you can see two of the tables we provide forecast. So this is the forecast which I had mentioned in the past. So this is with the report, keeping the report point of view in mind. We have the forecast here. So you can see we have two separate tables here, but when it comes to a report, we need one table so that we can have a common ground for both of these. So that's where the sysinfra tables come into picture. So these are basically called as aligned tables. So they copy data from both agent and agentless. The reason we do this is like when we looking back here. So if I want any information pertaining to my top 5 nodes, be it on any ground, it's not possible to get information on both agent and agentless by using two separate tables. You can't group by a union. So that's why we have a common table here for all of them. So you can, it's pretty self-explanatory. So the node copies data from your agent and agentless node, and CPU copies data from agent and agentless CPU. Same with the network file system and disk. And again, we have the same forecast which from the previous tables. In addition, we have an avail table. So this is for the availability, the uptime hours. It basically comes from your sysinfra node. So basically, it's again boiling down to using the agent node and agentless node. So moving on, this is the other content I'll be talking about, and that's events. So in events, it's a little bit of a different structure. So we have only one raw table, and that is OPR event, where all your event data comes in. And there are multiple ways these events get aggregated based on various conditions. So event summary is just the events that are present in that particular time frame. So be it the hourly time frame or the daily time frame. The open, the close events, or even the incoming events, and based on their various severities. So it goes into the summary table. So the same way, information pertaining to the particular CI, be the incoming, open, or closed events, they go into the CI summary. Similarly, for your CI type, we have the CIT summary. For the event type indicator, we have the ETI summary, and the incoming, open, closed events based on the policy type, we have the policy summary. The events can be assigned to a particular user group or a user. So against a user, the open, close, incoming events, they go under this user group summary table. And finally, the events assigned against a particular user, they go to the user summary table. So the aggregations we follow here for events are actually custom on the hourly and COSO on the daily. So now I'll briefly cover the content structure we have. So a little later, I will show you how you can see the structure of our contents using the CAS CLI, but this is how our contents are. So if you check any of our contents, this is the structure it follows. So first we have the OPR folder. Under this we have integration, and under integration we have 3 wings. So not much on the BBD wing. So these contain the .bbd files which pertain to our reports. So this is the structure we have. Under the BBD you have the dashboard folder. Under the dashboard there's a content folder, and under the content folder you'll have your .bbd files. So COSO is what is this part of the wing is more important when it comes to our content. So the first one I'll cover is metadata. So metadata contains your raw table JSONs. So again, you'll have the content folder, and under the content folder you'll have your JSONs. So enrichment contains things pertaining to your aggregations and forecast. So we'll have the JSONs pertaining to your hourly aggregations under this, and then your daily aggregations will come under the daily. And finally, the forecast JSONs come under the forecast. So in the previous session, a bit was covered on the custom tasks. So the anything pertaining to your custom task flows will come under rollup. So the Perl scripts, base64 encoded, go under your Perl, and any task you define need to go under tasks, and you can finally define your task flows under task flows. So this is the rollup part. Finally, I'd mentioned a few slides back about retention. So your retention JSON goes under this. And finally, we have the collection. So when you're using the agent metric collector, you would want to specify things pertaining to what are the metrics that are coming in, the mapping and the table mapping of metrics and the table mapping. And this is where the collection folder comes in. So everything gets mentioned here. And finally, like this is where your collection JSON would come. So this was a brief on the content structure. So now I'll be covering about custom content. So in the previous slide, previous few slides, I spoke about our sysinfra content. So the ones here you see in green are the metrics that we offer out of the box. So the disk metrics, so you saw on the disk table. So global is what we have for node. CPU goes into the CPU table. File system is for your file system table, and similarly netf is for the netf table. But in addition to this, we have a few in yellow. These are the ones which we don't provide out of the box, but based on your needs, you can use these other metrics. So the one in red is the process metric. So this metric cannot be summarized. So the CMI CMI tool can't help you much with this because the AMC can't pick this metric. So as far as these other contents are concerned, you can create your own content zips using the CMI tool. So I'll go into the CMI tool now. So what does the CMI tool do? So there are 4 tools within the CMI tools. Before I go into this, a little bit on this diagram while explaining these. So first I'll talk about the CODA object. So CODA is the agent database. So you can find the CODA object by going into any of the agent systems. So we have the CODA to Excel tool, which where you can specify which particular class under a data source that you want to pick for your need. And based on that, the CODA to Excel will create 2 Excels for you. So one will have the information pertaining to metrics, that will be your data source. And finally, the other one will have information pertaining to configuration. So just to go back here, so here the configuration Excel will have information pertaining to these, like as in what will be the hourly JSONs, the daily JSONs, the forecasts and stuff. Whereas the data source will have information pertaining to your metadata and your collection JSON. So now if I go back here, maybe it'll give you a better idea. So anything pertaining to your collector directly goes in from your data source. And finally, the metadata part 2 comes from the data source. The configuration helps you get information on the enrichment and the retention part. So this is where the second tool comes in. So you don't have to actually create these. So we have a tool called Excel to JSON, which consumes the data source Excel, and it creates the schema related folders under your OPR directory, and the collector related directory gets created by the collector one. So the collector one's at the top, which creates your AMC configuration, and the schema one consumes both the Excels, and it creates this directory here. Finally, once you zip it against the OPR and create your zip, we have a content deployment and validation tool. So this tool basically deploys your content in your system, and it also runs a few test cases just to know that it's all running fine and the content's been created the right way. So just like how does one benefit from it? It's much faster, so you don't have to remember the entire structure that I'd shown in the past, and you don't have to type out your JSONs manually. Everything is handled by this tool. All you need to know is what are the metrics you want and the collection frequency, the retention period, and what are the keys if you don't want to go with the default keys. So finally, this is a little bit on how the tool looks. So you can see here a few important things. I have underlined it. So the first one was a CODA to Excel. So so in this particular case, I have my CODA object captured as a text file. So using the CODA to Excel, I was able to create these Excel. So one is the configuration Excel, another one is the source Excel. So in this case, in the past, I showed you the scope class. So that's why this is the data source use scope. So these 2 tools consume these Excel. So the collector directly consumes the scope Excel and creates the collection JSONs here, and the scope and the collection are consumed by the schema tool, which creates the remaining ones for me here. So finally, this was deployed using the CDB tool into my environment, and just to show it worked, I have the tables created here, and you can see the data was being pumped into these tables. So now I'll talk a bit about the CAS CLI. So how do you get the CAS CLI? Before going into what it is, just how to get it. So it's already present under your static files under the patch. You get it in patch 2, it's present under the static files. So what is better with the CAS CLI? So I saw a bit of question about the renaming. So this is the change we have. So we no longer need to use the OPSB content service.sh that is inside your content admin pod. So the CAS CLI is something you can directly use from your host. So it's far more convenient because of that. You no longer have to put your content into a particular NFS location and then copy it into a location, access that NFS location from your pod and put it into the right place and then deploy it. You can directly consume it from your host itself. And it also provides you more options like downloading and uploading, which was not provided earlier. So a bit on what the CAS CLI provides. So the CAS CLI helps you with both content and collection, like how the content service.sh file used to help you. So on the content part, we have a few commands here. I'll briefly run through each one of them. So the upload with content point of view, you can upload your content as a file. It consumes the zip. and it uploads it. So you will every time whenever you upload a content, you will be, and it goes in successfully, you will be able to list it. So the only condition here is you need to have your content in the right format. So install whichever content is uploaded, you can install this content. This will create all the tables and all the information pertaining to the all the other information pertaining to the content. So you can also uninstall your content if you don't want to use it. And any content that is uninstalled, you don't want it any longer, you can delete it. So if you want to take a look at your content, you can download the content. So you will get the zip. That's what I was saying earlier. So if you want to see the OPR structure, you can download any of our content that we provide out of the box. So if you make any changes to your custom content and you want to install it, you can directly upgrade it against the right version. So whatever the content is present in your system, be it installed or not installed, you can use the list command. It will give you a good idea of what content is present and what is the state, whether it's installed or not. So describe is a useful command which helps you see that entire tree structure which I showed earlier with respect to your content. It gives you all the information pertaining to your content, and if there's some failure with respect to installation of your content, it gives you a few one-liners on where which particular part of the content did not install successfully. Finally, there's a convenient command here to set the retention directly. So you don't have to like modify anything in your content. You can directly change the retention period as and when requirement arises. From a collection point of view, again, you might see a few common commands here. So upload, you can directly upload the collection JSON. And then you can also delete a collection which is not running. So you, again, if you want to take a look at your JSON, you can download it. And using the list command, you can list out all the collections, the ones that are running or not running. You will also get a good idea of the state. So you can start any collection and you can stop any collection, or you can restart any collection. If you have made any change to your collection, you can just update it and against the right version. So a small overview of the reports that we provide out of the box. Again, I'll be covering more from sysinfra and events point of view because those have got a bit of a hierarchical structure. So these are the events that we reports that we provide out of the box. So we have the system infrastructure reports, and this is the list. I'll go into this in a bit. But again, against events, we have these reports. Against synthetic transaction BPM, we have 2 reports, and RAM again we have 2 reports. So this again, like this is pretty straightforward. So you have a summary report which drills down into detail. Similarly, you have a summary report which drills down into a detail. So these 2 reports in the upcoming slides, I'll cover a bit in detail. So coming to the system infrastructure report, the main high-level report is your system executive summary, which gives you all the node-level information that you need. It gives you information about top node. In the next slide, there'll be a bit of a few screenshots to give a better idea. So the system executive summary basically has all the high-level information as about regarding availability, CPU, file system, disk usage, and stuff like that. So from the system executive summary, you can easily drill down into these reports. So the first report being the availability top n. So this will give you information on the top n most and least available nodes, and your system availability detail gives you, again, it's a drill down on the availability. So here you can see you can directly drill down to it from the executive summary, or you can further drill down to it from top end. So maybe in the next slide, you'll get a better idea how this works. Then you can also drill into your CPU report, which will give you top end CPU, and this can further drill down into the system resource detail, which will give you information for that exact node which you want to check. Similarly, we have for memory and disk. They all drill down into the same resource detail report. In addition to this, we have system resource top 3. It doesn't, the reason it's not added here is because it doesn't drill down from the summary report, but it's a good report to have, which gives you information on top 3 on a few things like swap util and other important metrics. I think I missed out on the disk space report. So disk space report drills down into the disk space detail. So just to give a better idea of how it looks, I have a few screenshots here. The use case here is CPU, but I will go a little bit into detail on the executive summary part. So here you can see the executive summary. This particular gauge here gives you information on the availability of all your nodes actually. So in this case, all the nodes are 100% available. So you don't above 90% available. So you don't see much, but basically from here, I can drill down into my availability top n, which is shown here. Or if and here you see least available nodes. If I want to drill directly into the node, I can just click on this. It will give me information on any of these least available nodes. Similarly, in this use case, as you can see, I've gone into the CPU report. So here you have it shows you how many of the nodes have CPU utilization less than 10%. And in this case, you can see we have like a lot of nodes here, and there's very few in the alarming region of more than 90%. So here you can click on the CPU, and this will drill you into this report. So this shows you the systems by CPU utilization top n, and bottom n. So this 5 is just a parameter. You can go from 5 to 100, I believe. So from here, if you want to look into any of your nodes, you can just click on them, and that will take you to the system resource detail, which will give you further information regarding the CPU and the memory. Similarly, you can do the same with the file system. This actually goes into the disk one, the disk space report, and you'll know the disk consumption on each of your directories. So coming to events, it's not that complicated. So we have the event executive summary. I don't have any screenshots for this, but it's the structure is somewhat similar. So in event executive summary, you have again, it's a high level report like a system executive summary. So from here we can drill down into 4 reports. So event executive summary lists out events based on user group. So by clicking on it, you can drill down to the event assignment by user group. And further, if you want to know the event is the particular events assigned to which user, you can go into the event assignment by user report. Similarly, we have events by configuration item type, which can again, you can drill down from executive summary. And further, if you want to get information on that particular configuration item, you can drill down from this report. So we have 2 other final drill downs, the event by policy and ETI, which will give you information on the events based on the policy type and event type indicator. So last is a little bit on the customization. So in all the reports that we publish in Marketplace, we also provide for customization for our customers, which means we ship the Visio and the SVG with the reports. So based on your business needs, if you feel like you want something extra into your reports and something is useless and you want to swap it out, so you're free to do so. So that you can customize your report based on your liking. So the next 2 points are a bit of best practices what you can follow when you're customizing your report. So the first one comes into picture when you're working with your Visio, and that is using a proper placeholder. So it's a common practice while designing UI to assign values to your widgets to know how the prototype would look like. And in case of reports, that might be quite a confusing thing, because assigning something like, just going back here, assigning something like 100% in your Visio would be quite a confusing thing, because when you render it as a report, and even if there's no data flowing into that widget, you would get confused thinking it's actually 100%. So it's a good practice to name. So what we do in our reports that we ship out of the box is all the value widgets, we name it as value, so that you get a clear idea that when there's a value there, it's actually value coming from your database. And the second point we have here is more important, and that is getting most out of your queries. So since we provide both raw and aggregation tables, there might be a good question as to where do you get the trade-off, best of both worlds. So of course, it wouldn't make any sense to have all the data coming from the raw tables. That would tax your DB. At the same time, just getting all the data from your aggregate would mean you might miss out on some crucial information. So what we do with our queries is we do a union between both raw and aggregation table, keeping the time difference in mind. So any data that comes where the time gap is less than a day, it's wise to take data from your raw tables, so that you get more data points in a short time frame. And when the time frame increases to more than a day, what you can do is you can take data from your aggregate tables. That way you're not taxing your DB too much. So we'll move on to the Q&A section. Are there any questions?
Yeah, there's a question here about the customizing reports. We don't have Visio files for the reports. We have only the BVD files. How can we get the Visio files?
Okay, I'm not entirely sure. Krishna, can you take that?
Sorry, can you repeat?
Yeah, the question with the contents that was shipped by Operations Bridge contains .bvd file that is
Correct.
loaded into the BVD.
Yes.
In case if we want to modify that one, we want the Visio file, not the BVD
Correct.
file.
Yes, you're right.
Where we can download this one, or how it
Okay.
can be
We have a marketplace release last sprint on last release onwards. So we have system management, Visio files, as well as event content pack. Both are there in the marketplace. You can download it.
Very good. Thank you very much.
Yeah, I have a question, please, regarding the retention. So, so how long, how far I can report for the last quarter, the last, and of course, I guess the granularity will affect that as well, right? The older you go, the less granularity you'll have.
The retention which you are talking about and the source data granularity or the Vertica retention means your raw data, how many years, how many days, that one you are talking about, or the source data granular?
No, I'm talking about what's going to be shown on BVD. So basically, what's coming from Vertica, what I can show as a report on BVD.
Correct. So that is from the Vertica.
Yeah.
So your question is, can we extend or something? You are.
Yeah, I'm just curious, like how far I can go as far as reporting. Is it a year? Is it configurable?
This in the report, you still can select your calendar start date and end date, and you can select it, and whatever the data it is there in the database, that you still can pull it into the Vertica, into the BVD report. But there is a, I mean, that refresh time limit is there. So normally, for the analysis of the reports, it may not be last 2 years, right? So for that, we will request to export into PDF format by using Web2 PDF. But there is no restriction on the BVD side. You can still select your start date and end date from the calendar side.
Okay. So there'll be retention policy on the Vertica side then. How
Exactly.
far I can.
Yes.
Yeah. I can add also one point here. There is already with the contents, there is retention policies per data type, yeah, like daily data, hourly data, stuff like that. There is default values on them. If you want to modify them, you need to use the CLI tool, the CAS CLI tool, export them, modify the value, and upload them again. So after that time, the system will not delete the old data points that you have. But there is already a configuration that is in place to ensure the data will not increase forever.
Okay. And all this is documented, right, in our documentation?
Yes, it is documented. Yes.
Great.
Yeah, just to add, Bhupendra here. So by default, all the tables, whatever we create as part of the contents, we provide the default retention settings. Let's say for the daily tables, it is 5 years, or for the raw tables, it is for 60 days, and for hourly, maybe 180 days. So this is provided out of the box. And as Mahmoud also added, if you want to customize it, you can customize it using that tool which just now Rahul explained, the CAS tool. Yeah.
Okay, great.
Yeah, I have a question for the custom contents for the new tool that we have developed, which can read from Coda and then push it and then create a content for COSO to use the agent metric collection. The question here, once I connect to Coda and make everything and make the content and everything is fine, then the agent metric collection is instructed to connect to these clients to fetch the data. What if I want to configure a policy to send and then select these specific data sources and send them to the receiver? Is it working? Is it going to work in the future? Do you have it in a plan? Stuff like that.
So you're trying to stream the data, is it?
Yes. Sorry. Yeah, it's a stream data.
We have a doc for that actually. You don't have to use. So the only constraint here is streaming doesn't support anything outside out of the box. So whatever you see in green, so those are the only things supported by streaming. So here you don't even need the CMI tool basically. So whatever are the metrics that are provided by these, you can customize them. There's a doc provided. for the
Yeah,
custom metric stream.
I mean, if I added something with the custom metric collection, by default it uses the agent metric collection to go and pull the data.
Right.
Okay, but at the same time the topics are created, the receiver is ready to receive this data, everything is fine from the streaming point of view. Is it supported? Is it today with this metric collection, with the custom metric collection, is it supported today to do streaming, or it's only about agent metric collection?
It's only agent metric collector.
Collection.
Streaming is not supported. It's supported, as Rahul mentioned, only for system metrics, and that too these classes, the green classes. And if you want to
add
further
to this, please,
customize,
I suppose Mahmoud's question was actually related to third-party tools delivering those metrics into the scope and CPU tables. Am I right, Mahmoud?
If you want, you know, we have already few metrics under CPU. If you want to enable further more metrics which is not collected, that you can modify the policy and add those metrics. For that we have a documentation.
No, I don't need adding metrics that that COSO doesn't know about yet. We're talking about tools other than the microfocus agent and other than SiteScope delivering those metrics that COSO already knows, such as CPU utilization coming from Nagios or something. Is that support? Is that possible today? Can you stream CPU utilization from a third-party monitoring tool into COSO?
The idea is how to add data for the sys infra tables. This is the underlying question.
Basically, yeah. Or it could be
Sorry,
agent or agent-based, agentless as well.
Sorry, guys, you hijacked my question. My question was as simpler than that. Okay, I am talking about the CODA situation without going to the other extensions that you mentioned, which are good also. But I'm just saying that I am connected to CODA. I selected a new data source, and then now agent metric collection is ready to collect it. That's correct. What if I configured a policy, a streaming policy, and I selected the same data source and supplied the receiver of the COSO receiver that already has the tables, everything is there? Is it supported or not? You mentioned not. If it's not supported, do you have a plan to support it in the future?
In the future, we have an enhancement request. We have raised an enhancement request, Mohammed. So I think it's under PM's call now when to implement that part. Yeah.
Okay. Then let's go to the questions of our colleagues here. They are asking about streaming with open streaming, let's say, call it this way.
Third-party data sources to deliver metrics that are not exactly custom. Point is, I've been in discussions with Hyperosa for quite several months, actually, and we have several deals with large partners like Wipro, and that capability is actually sort of key to several of their custom architectures. So, and I think there was a misunderstanding with product management at some point because everybody keeps referring to custom metrics. And I think the understanding of those people is that custom metrics would actually refer to metrics other than CPU utilization, disk utilization, and so forth, but rather new metric types, which is interesting as well, of course. But the core question is really well-known metric types, such as those that we officially support with our data sources, but delivered by a third-party data source. So how does that stand? Can someone easily go ahead and have Nagios deliver securitization through the streaming, through the HTTPS receiver into COSO with it using the standard data schema, but from a custom connector?
Yeah, this is a valid question. I think as of now, we haven't tested that flow, and then we don't know as the R&D team. Mostly, I think Herald have this. Herald Boros might have this information, and then their PMs might know when it is coming.
Yeah, I can answer this part simply. If you connect to any data source and you created in CODA or a scope as a data stored in the agent or the third connector or OPS bridge connector, then you can use the custom metric collection tool to take this data. This is the only way today. But to connect to them directly or them to send data directly through streaming is not yet supported.
Yeah,
you have to
right.
stage
That's what
it
Howard said.
in the scope.
Missing it.
You have to stage it in the coda or scope. Then from that, the new tool that was just released can be used for that.
Yeah.
Yeah.
Yeah, I guess
Right.
it's rather a question of the connectors when they implement that, such as the integration hub. Yeah. Okay. Okay. Thank you. I think it's actually really a roadmap question.
Yeah.
So. Rahul, you have muted yourself in case you're speaking.
No, I'm
No,
waiting
are
for
there any more
Alexis.
questions?
Alexis, any questions?
All right. So how are we going? How are we doing on the question side right now?
Yeah, I have a question maybe or an ask for the custom metric collection. I think as per my communication with Alexi, we don't have a lab for this one. Can the R&D team share with us some videos on how this is working, like some, let's say, exercises they have done or something like that? We can add it to the course material without more training. I'm just, if it's already recorded somewhere, it will be good.
I think, Mahmoud, that it's a question more relevant for a SWAT team that tests those scenarios, right? I think from R&D perspective, that would be maybe some QA material, but I don't think that I ever saw a reference to a documented piece outside of the SWAT team.
Yeah, it's not about documentation. I have seen materials from the R&D, let's say when they were creating the Exchange Management Act, okay, in the custom metric collection, some discussions like this. So if they have like a good recordings where they can share with us the commands to take data from Coda to Excel, and then from Excel to make modifications, and then to create the content back. These kind of demos, small sections, if we have it, it will be great.
Yeah.
That's it. Maybe it's not a valid request, so maybe
No,
ignore it. It's okay.
So just one last question, please. Just the use case for Coda for the custom. Can you just give me like a good use case, a practical use case for that, for the custom ingestion and custom Coda use case?
For example, suppose by default here, if you see here, we are writing a disk global and CPU file system native, and we are not supporting for L volume, core, and configuration metrics or any of the application transaction metrics. It's not there out of box. And in that case, this is for the system management. And you have another Coda metrics for applications like WebLogic or WebSphere that also will coming, but another management packs. Okay, you have already in the system, and then you want to push the data into COSO and then see the BVD reports. So these are not available out of box. So in that case, we can use this tool and generate the content or generate the COSO zip and then install it, so that data will flow, and then use BVD to create a reports on top of that.
Okay.
Okay, so I have a another question. So I don't get how I get the CODA tools to create the custom content.
For the CODA tool, I think this is already shipped in this release 2020 10.v2 via marketplace.
On the marketplace, okay.
Yeah, you can download that part, the CMI tool. I can give the link also. I will type the link here.
Yeah, okay. And I have a simple use case. If I have CSV files which contain custom metrics, can I use CODA tools and custom content and create a custom content pack to stream this data from the CSV file to COSO and create later some
your data source is CSV, right?
Yes.
Not CODA. Okay, that is not here again. It's not in the support scenario at present.
So it's not supported. I cannot read some data from CSV file and push to COSO.
As a capability, we have, but as a supportability, I mean like something that you can open support cases and you get help from R&D is still not documented. This release, they were working only on the CODA metric, not the CSV. So the only path, if you want to do it today with the current supported CMI, is to load these CSV files into CODA scope through policies, and then you can ingest it from there.
Okay.
That is the direction. Okay, we have already some practitioner notes in the documentation that can help you if you want to go through CSV, but it's not. Yeah, for example, I did this with COVID data. I did this in a few years. Yeah, that's just last year. Yeah, okay. In April, it was CSV ingestion, but it's not supported. So I was doing it alone. I was messing up with the database, with the Vertica and everything. And if I open a support case, nobody can help me because they don't have, they did not have the guidelines written on the right way that should be used by someone. But since I was reading the practitioner notes, I was able to do that. But you know, for a small scale like daily data, it might not impact your system, but for larger data sets, it might cause issues. So that's why we keep it for the R&D to support it, because they are not only supporting the size, they are also supporting this with real guidelines, like what is the right way to create the tables, the dataset naming, the column naming, these kind of things. So that's why we give it time for them to do supportability, let's say future supportability.
Okay.
Okay.
Thank you.
That's it. Most welcome.
All right. Well, I just want to thank everybody for your questions and for the presentations. It was really great. And it's time for us to take a little break. And in half an hour, we'll have another presentation. So Raul, thank you very much. Uni, thank you very much. And I'm sorry I did not capture the last gentleman's name. Just 1 second, let me find. And thank you.
Krishna, Uni.
No. Okay. Yeah. So anyways, thank you so much for your presentation. I will see you next week. As you see, those discussions really sparked a lot of interest and understanding in the COSO world. And it's scary only if it's unknown. So we definitely are tackling this part. Everybody else, we have another presentation from the Technical Success half an hour from now. So let's take a little break. We'll return for another presentation, and then it's going to be just a lot of work to do.
Thank you,
you.
Alex.
Thank you, team.
Everybody.